In this video, we'll be looking at lesson 1.8. This is our last lesson in factoring. It's a special case when we're dealing with difference of squares. My essential question will be, how do I factor a difference of squares? The first thing I want to talk about is exactly what difference of squares means. So we'll write difference of squares means subtraction of two perfect squares. Perfect squares being something like x squared, or maybe x to the eighth, and then, or in our numbers would be something like 4, or 16, or 9, 64, 81, 49, numbers like that. So something we need to recall that a plus b times a minus b is equal to a squared minus b squared. So this is what we did in a previous lesson, lesson 1.4, when we looked at our special products. And then all I'm doing right now is just recalling this information, because remember, factoring is just starting at this end and converting it back to our factored form before we multiply it. So I'm just going to go backwards from here to this beginning kind of stage. And I'm pretty sure I said in that lesson 1.4 that this would be the important one, and lo and behold, here it is coming back. So in my factored form, so I'm factoring a squared minus b squared, and that's going to equal, just going backwards, a plus b times a minus b. Okay, so let's do some examples. If I have x squared minus 4, I'm just going to go backwards. I'm going to do some side work underneath to show where these values are coming from. I'm really just taking the square root of both numbers. So we can say the square root of x squared is x, and the square root of 4 is 2. Now I know what my a and b are. Here's my a, here's my b. Plug into our formula. So I'm going to get that my answer is x plus 2 times x minus 2. That's it. So at this point, will you try this one? So if you want, pause right here. You can try this one on your own. So I'll do my side work underneath. Square root of x squared equals x. Square root of 9 equals 3. So I have my a and my b. A is x, b is 3. And I plug in to my formula, and I get x plus 3, x do another type of example, kind of up the ante a little bit. So number 3, we're going to have 4x squared minus 25. So doing my side work, I have 4x squared is equal to 2x. The square root of 4 is 2. The square root of x squared is x. And then I have the square root of 25 equals 5. And here are my a and my b. Plugging in to my formula, and I get a is 2x plus b is 5 times a is 2x minus b, which is 5. So 2x plus 5 times 2x minus 5. Now, if you want, please try this one on your own. Pause right here and try this one on your own. Okay, I'm just going to show my side work. You don't have to always show your side work. I'm just showing it so in case there's any kind of confusion, we can see where these numbers are coming from. So I took the square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. And I took the square root of 16. Square root of 16 is 4. And now we can plug in our a and our b into our formula. And we get 3x plus 4 times 3x minus 4. So I have one more example that I want to try. And this is going, I'm going to need some more space to do this one, so I'm going to do this one on the back. We're really going to step it up on this one. And this is going to be a situation where I perform difference of squares factoring twice. So we'll do a difference of squares, and then who knows, maybe another difference of squares will pop up. So let's look at x to the 8th minus 16. Doing my side work, I get the square root of x to the 8th is x to the 4th. Square roots cut exponents in half. Then I do square root of 16 is 4. Plugging in my a and my b, I will have x to the 4th plus 4. Then I'll have x to the 4th minus 4. And look what we have here. We have another difference of squares. So I can separate that one again. So doing my side work, I have the square root of x to the 4th is x squared, and the square root of 4 is 2. I'm going to bring down my first one. So that's just coming straight down, x to the 4th plus 4. And then I will use my a and my b to separate or to factor this new difference of squares. So I'll have x squared. So I'll have x squared plus 2, and then I'll have x squared minus 2. And then we're done. If there's more difference of squares, keep going. We don't have a sum of squares. No such way. There's no way to factor a sum of squares. So we won't even think or worry about that. It's only when there's a difference being that subtraction. So don't worry about a sum or addition of squares, only worry about the difference or subtraction of squares. So if you would like, I have one more that you can try on your own, similar to the one above, x to the fourth minus 81. So you can pause right here and try this one on your own. So if you took the chance to try this one on your own, showing my side work to help me think, I have x square root of x to the fourth is x squared, square root of 81 is 9. So that's going to tell me that I have x squared plus 9 times x squared minus 9. Here's another difference of squares. So I can look at the square root of x squared is x, and the square root of 9 is 3. Bringing down my x squared plus 9, and then factoring my difference of squares, and I get x plus 3 times x minus 3. There are no more difference of squares. Addition, addition. Here's my only subtraction, and these are not perfect squares, so I'm done with the problem. So thank you very much for watching this video, and I hope you have a great rest of your day.